Okay, let's get started. Good morning, everyone. Welcome back. So, last time we talked about chapter 4, which is about what? Which is about the participating in electricity markets. And as you remember, we have three types of players: generator, consumer, and retailer. And last time, so we discussed consumer, we discussed retailer, and we were discussing generator's perspective and suspended. So let me keep talking about the generator's perspective. So yeah, consumer, retailer needs to buy energy from the wholesale market and sell it to the retail consumers, and there is a price margin, blah blah blah. So generator's perspective, monopoly, duopoly, oligopoly, and perfect competition. So last time we talked about perfect competition. Oh, I think one student is missing, and that is Jeon Ji-hoon. Yeah, and the reason I remember that is because he asked the question about the bidding strategy in this perfect competition. Yeah. The most ideal case, perfect competition, means all participants are price takers, which means they cannot affect the price. Or we can say the market share of each participant is negligible. Okay, that's the meaning of perfect competition. And this is microeconomics perspective. So our aim is to maximize the short-run profit. So when they are price taker, this price is given. Then when this price is given, the generators needs to determine how much I need to produce. So here Y is the output of the generator. So this is a simple optimization problem. So you remember that. So they need to determine the production quantity where this marginal cost of generation is equal to the market price. So a few examples, blah blah blah. And also, yeah, the generators need to schedule their power plant considering startup cost, operating constraints, environmental constraints, and other revenue opportunities, etc. So we talked about the convex optimization stuff and the meaning of Lagrange multiplier lambda. Lambda plays as a shadow price. So, okay, so in this perfect competition case, you are a generator company. You are an operator of generation company. Then you need to think about your bidding strategy, and you know your marginal cost of your generating unit, and what should be your best bidding strategy. And actually the answer is, since there are a lot of small producers, this is perfect competition again. Honest bidding is your best strategy, which means your bidding should be your marginal cost. Okay, that's the answer, and let's think why that is true. So if I bid at my marginal cost, I get paid. By the way, so when we solve the optimization problem, no. So you remember this supply and demand curve. This supply curve is constructed from what? The bidding from generators, right? So if they so it reflects the marginal cost of each generators. And when it is market clearing price, you remember that all the producers who bids less than this market clearing price will get paid at the same price, right? So that's the key point. So we have let's think about, we have a market price. This is determined from the market in this perfect competition. and everybody gets paid at this price. Suppose that your okay. So suppose that your marginal cost is here, marginal cost of your generator. And actually, we don't know where the market clearing price would be determined. So this is my marginal cost. So you have three options. 1, 2, 3. This is overbidding case. Your bidding is higher than your marginal cost. Why do you need to do that? So please don't be confused that you get paid at the market clearing price, not by your bid. Your bidding just determines whether you are selected or not. Okay? All the bidders get paid at the same market price. Okay? So what I want to say, suppose that this is your bid here. Yeah, and if the market price is here, anyway, you will get paid at this price. Okay, so that's okay. But if market price is here, that means you are not selected because your bidding is higher than the market price, and you are excluded. You are extra marginal producers, so you cannot participate in the market. So you lose money. If you bid honestly, you can get into the market and make profit. But overbidding is not good in that case, right? So yeah, this is not good. And so option 1, option 2, option 3. And if you underbid, let's see what happens. If the market price is here, anyway, you cannot get into the market. So no. But if the market price is here, what happens? If you bid honestly, you cannot get into the market. Actually, you don't need to get into the market because your marginal cost is higher than market price. So you can, if you participate in the market, you lose money, right? So you'd better not go into the market. But if you underbid, you are selected, and you pay what? You pay this much. This is smaller than your marginal cost, so you lose money, right? So honest bidding is your best strategy under this perfect competition. Okay, so that is described here. Yeah, if I bid at my marginal cost, I get paid the market clearing price if I'm the marginal or inframarginal producer. If I bid higher than my marginal cost, I could become extra marginal and miss an opportunity to sell at a profit. And if I bid lower than my marginal cost, I could have to produce at a loss. Okay, so we talked about these two cases. So there is no incentive to bid anything else than marginal cost of production under perfect competition. And okay, so marginal, inframarginal, and extramarginal producers. You remember this. By the way, so we sorted the bidding from increasing order perspective. Okay, so this is the marginal producer, quantity and price. Yeah, marginal producer, inframarginal producer, and extra marginal producers. And please remember that everything is sold at the same market clearing price, and the price is set by the last unit sold. So the price is determined by the most expensive generators. Okay, every generator gets paid equally. Okay, so marginal producer sells this last unit, gets exactly its bids. Inframarginal producers get paid more than they bid. This is a good thing. Okay, even if they bid honestly, these infra-marginal producers get paid more than they bid, and they can collect economic profit. So even if we are focusing on short-run case, these infra-marginal producers can make money, and they can use that money to cover their fixed cost. Okay, so in this short-run analysis, we ignore the fixed cost and startup cost for simplicity. But anyway, these infra-marginal producers can use the earned money to compensate the fixed cost and startup cost. And extra-marginal producers, they cannot sell anything. Okay. So yeah, we already talked about it, but let's see the animation. Profit of an infra-marginal producers. This is the bid sorted. It's an increasing order. And so supply curve and demand curve. This is the market price pie. And yeah, for this, we suppose that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 companies. So infra, a marginal producer. So this is marginal cost. So integration of this is the cost, total cost of the company, and this is the revenue, price times volume. So this is the revenue. So revenue minus cost is the profit of the company. So the sum, you remember that the sum of these profits is the welfare of the producers. So selling at marginal cost covers the variable cost of production. And the difference between the market price and the marginal cost must pay for the fixed cost. So the fixed cost means startup cost and no load cost, and the cost of building the plants, the capital expenditure. Or they need to pay the interest for the bank and dividends for the shareholders. Okay, and yeah, so a power plant must therefore be infra-marginal often enough to cover its fixed costs. So yeah, which means their power generation should be efficient, right? Market price is higher than marginal cost for enough hours of the years. And the profit of marginal producers, actually, they earn nothing. Their revenue is equal to their generation cost. So no economic profit. So yeah, profit of marginal producer. If a marginal generator bids at its marginal cost, it makes no economic profit. So it covers only its variable cost of production, but anyway, no profit. So they cannot cover their fixed cost. So if generators are too often marginal or just below marginal, if the generator's marginal cost is equal to the market price or just below the market price, they cannot recover their fixed cost if they bid at their marginal cost of production. So in this case, they may want to bid higher than their marginal cost. Suppose that you are a marginal producer. So even if I get into the market, the sales and costs are same, so no profit at all. So you cannot compensate your fixed cost. So they may want to bid higher than their marginal cost, especially under imperfect competition. Okay, so they must include part of their fixed cost in their offer price. Offer price means bidding price, and their offer price is therefore higher than their marginal cost. They can do it because competition is not perfect in reality, and especially when the load is high and most generators are already producing. That means that at the time there is very little new producers. very little new producers when the load is high. Okay, so this is an interesting point. From marginal producers' perspective, when there is a high load and when the price is high, all the generators are already producing the power. So there is very little power generation company who can further produce power. So this cannot be a perfect competition. This is imperfect competition. So our assumption of perfect competition is not valid here. So they may want to tweak or exercise their market power. Market power means you can think market power is almost same to their market share. If they have a high market power, that means they have a large volume of market share. Okay. So they want to bid higher than their marginal cost. So interesting thing happens in this area. So let's go to that part. Imperfect competition. Any questions so far? Okay, imperfect competition. And because this is imperfect competition, the players here, the producers, the generation company, needs to have strategic decision, or that is called strategy or action. So strategy, action, those terms are used interchangeably. Mostly the game theory book use strategy, but your textbook use action. Anyway, so each firm must consider the possible actions or strategies, actions of others when selecting a strategy. In perfect competition, I don't need to care about others. Okay, I only need to focus on my strategy. That maximizes my profit. I don't need to care about someone else. But in this imperfect competition, I also need to consider other players' action strategy, because that affects my profit as well. That affects the price as well. Okay, so that's the game theory. The game theory means that my profit depends on my strategy, my action, as well as other players' strategy. So that's the difference between optimization and game theory. In optimization, you only need to focus on maximizing my profit. The variable is just my strategy only. But in game theory, I also need to consider other players' strategies. Okay? That's the key difference between game theory and optimization. So classical optimization theory is not sufficient here. And game theory is a huge field. This is a one semester course, so we only briefly talk about that. One of the example is two-person non-cooperative game. So there are two players and non-cooperative. Another branch of game theory is cooperative game theory. So we have one firm against another, or one firm against all the others. So in this case, two firms. In this case, n firms, but one firm and n minus one firms. They behave same, just for analytical purpose. Okay, and in game theory, Nash equilibrium is important. And what it says is, given the action of its rival, other players. Okay, so at Nash equilibrium, this thing happens. If other players do not change their actions, I do not change my action either. So if you keep your position, I also keep my position. That's the meaning of equilibrium. So the meaning of equilibrium is there is no change. So as long as you, so as long as you love me, I love you. Okay? So this kind of thing. Yeah. This is not unconditional love. This is conditional love. Okay? As long as you love me, You know, that kind of song, you know what I'm saying? Yeah. What is the title of that song? Yeah, the lyric flies over my head, but check it. So that's the meaning of Nash equilibrium. And let's think about this imperfect competition using mathematical analysis. So here, omega f is a profit of form f. Okay, and the profit is the revenue minus cost, and this pi is the market price, and this pf is the power generation volume of form f, and cf is the cost of form f. Okay, so yeah, and here this xf is the action of form f. This action can be either the generation quantity or the price you want to sell at. Okay, so here we will consider two types of game theory model: the price competition versus quantity competition. The price competition means that your strategy is, I don't want to sell power below this price. Okay, so that's the strategy, the price action. And the quantity can be your action as well. That means I want to generate this much. Okay, and actually the total volume of all the generation from all the companies will determine the market price. So either price or quantity affects each other. So your price can be your action, or your generation quantity can be your action either. Anyway, this xf is a generic term, so your action. And x minus f means the actions from all other players. Okay, so this minus f notation is very common in game theory. All others except me. And the Nash equilibrium mathematically means this inequality. So this star means the equilibrium point. So at the equilibrium, the action of each firm satisfy this inequality. This means if you at the equilibrium, if you don't change your action, x star f, this is my best strategy. No. This is greater than or equal to all other my actions, given your action. Confusing? So, okay, xf star and x minus f star. This is the equilibrium point. That equilibrium point is called Nash equilibrium. And at that equilibrium point, what happens is, this is the conditional best strategy. As long as you do not change your action, I would not change my action. So they stick to their equilibrium strategy, xf star or x minus f star. That's the meaning of equilibrium. Why is that? Because if other guys do not change their actions, this is my best strategy. Okay? So this is a conditional best thing. The conditional means other guys keep their position, keep their strategy, keep their action. Okay, so please remember this relationship, this inequality at the Nash equilibrium point. And obviously, Nash equilibrium was suggested by John Nash. I told you, I saw him before he died in 2011 when I worked at Bell Lab. He gave a talk at Princeton University. So I visited Princeton. Is that correct? When I was a postdoctor at Princeton University, he was a professor at Princeton University in the Department of Mathematics or Economics, I don't know. So he gave a talk about his work his work of PhD, 1950 something. And he used the OHP film. You don't know what that is. So when I was your age, when I was your age, I drank latte a lot. And when we present, actually we do not have this kind of nice facility. So we have the optical, how can I say, overhead projector. So that is an optical device. We have a lens here, and there is a light, and then you can put transparent film, and we can print the document on that film as you print something on your paper. Okay, so put it on the light source, and then it projected. Okay, so every page I need to change this slide, and he did that. Anyway, he passed away after 2 years because of a car accident at New Jersey Turnpike Highway. Anyway, so we will discuss two models, which are very simple model, a classical model. And yeah, the first one is called Bertland model. And this is called game in price. Again, so in this case, game is price is your strategy. So your strategy, action is your price. And the meaning of this is that you don't want to sell below this price. Okay? So in this case, your revenue is price times the volume. And here the assumption is that the generation quantity can be observed in the market totally. So yeah, this PF is a function of my action, price, and other players' action, the price. So when there are only two firms, if my price is less than other players' price, I can take the whole volume in the market. Actually, yeah, less than or equal to or less than. Yeah. Otherwise, I lose the market in this two-person game. Okay. Yeah, I mean, yeah, this is a theory, but kind of okay, because when you buy some good in coupon, you are trying to find the producer who sells at the list price, even by one difference, or 101 difference, something like that. Yeah. So when there are just two companies, the one who offers smaller price will take the whole volume of the market. Okay. So in this example, suppose that we have two generation company, A and B, and their marginal cost is $35 and $45. By the way, I'm sorry, this kind of notation is used in the textbook. Yes. So normally I used dollar per, no. Normally I use this kind of notation, but strangely, this textbook uses this kind of notation. Yeah.
I think that nowadays most of the people use the second one.
This one? Yes. Nowadays, yeah. Most people. Are you sure? Okay. So this is the marginal cost, and this is the volume of company A and company B. So this is the cost. Then what is the bid by A and what is the bid by B? And what should be the market price and what is the quantity traded? And for this simple analysis, we use this simple inverse demand curve. So demand curve means D is a function of price. Inverse demand curve means the price is a function of demand. Okay, so in economics, this is the quantity, demand, and this is the price. So the curve that looks like that is called inverse demand curve. If you want to interpret this price is a function of demand, right? That curve is called inverse demand curve. You know that. You remember that. You remember you learned that. Yeah. You learned that. You don't, even if you don't remember what it is, you remember you learned it. These two things are different. Yeah. Anyway, so we have this inverse demand curve. And yeah, marginal cost of firm A, $35. Marginal cost B, $45. So A will bid just below $45, just 45 minus 1 cent, for example. And B cannot bid below $45 because it would lose money on every megawatt hour. So because in this example, in this imperfect competition, the market price is just below $45, $44.99 per megawatt hour. And the demand here is using this one, using inverse demand curve. Yeah, when the market price is that, demand is 55 using the curve, then and firm A takes all the volume. Firm B takes 0. Then yeah, so you can compute the revenue and the profit. Revenue is 45 times 55, and the cost is 35 times 55, and the difference is the profit. And the company B, their revenue is 0, cost is 0, and profit is 0. Example 2, when these two companies have the same marginal cost, what would be their bids, what would be the market price, what would be the quantity traded, and actually they cannot bid below $35 because they lose money on every megawatt hour. So anyway, their bid will be both $35, okay, and then the volume would be 65, and that is equally divided into two firms. Paradox of Mautland model of imperfect competition. In the case of ideal generators, both of them bid at marginal cost, and when the marginal costs are different, the cheapest gets the whole market, and this is too much simplified. So let's consider another strategy. So this is game in price, but not quite good for electricity market. And let's consider, yeah, is it a realistic model of imperfect competition? No. So another model is called Kruno model. So this is called game in quantity. So here, we have Form 1 and Form 2. And because this is imperfect competition, the price of the market depends on the volume. Okay, so pi is a function of the quantity Y1 and quantity Y2. Okay, and this is from Form 1's perspective. So that's why we put E here. This E means estimated. Estimated, so there are two players. I need to determine my quantity because this is my strategy in this game. But I also need to think about the market price, and the market price depends on the total volume. So I need to estimate how much my competitor would generate. Okay, so this is my expectation or anticipation, prediction. Okay, so based on the total generation quantity, the price is determined. And this is my, so price times quantity is the revenue, and this is my cost. And I want to maximize the profit by changing the production quantity. Okay, so here Y1 depends on Y2 estimated value. So there is some function that is called F1. Similarly, Y2 also depends on Y2 things the same logic. Right? So Y2 is also a function of Y1, the expected value, anticipated, predicted value. So at Coulomb equilibrium, Y1 star or Y2 star, they satisfy these two equations. There are some functions, F1 and F2. So Y1 star is a function of Y2 star, and Y2 star is a function of Y1 star. And where is a simple model? Yeah, so for simplicity, we focus on short-run profit maximization with market power. And for simplicity, just suppose that we have two firms. Okay, here we have n firms, but just for simplicity, let's assume we have only two firms, two generators. So yeah, this is what we discussed. And Y1 plus Y2 is the total industry output. And so the firm I wants to maximize its profit, so need to take the derivative of this profit with respect to yi. And again, this market price depends on the total volume. So take the derivative means pi y plus yi times the derivative of that minus the marginal cost. So this should be equal. Straightforward. And by the way, in the case of perfect competition, I cannot affect the market price. So this is 0 in the case of perfect competition. But this case, this is imperfect competition. So we have some value. Okay. When I decrease my generation unit, generation quantity, maybe there is some shortage in the market, so the price may go up. Okay. So this is not 0 because of market power of firm I. So slightly rearrange the term. So pi I, put pi, so pi, and yi. So you can change this to that. Yeah, just it is, these two things are same. And okay, this equation is repeated in the first line for your convenience. And so let's say this quantity, this one, this is here. The inverse of that is there. And the meaning of this is what? You remember this. How much the production quantity changes is a function of the price changes. If the price increases by 1%, how much I need to increase my generation quantity? Something like that. So that means the price elasticity of supply, typo. So that's the price elasticity of, that is price elasticity of demand. So what we want to do is so here the assumption is that anyway the market will consume all the generation quantity, and so Y is the total demand in the market. Okay. So this is the price elasticity of demand. Okay, so when the price changes, how much the demand will change. And then this one, the my generation quantity over the total volume, that is my market share. Right? So SI is the market share of generator I. So this equation can be expressed in that way. So this is SI. Anyway, this is a negative. So we put minus sign here. And the price elasticity of demand, we put absolute value there. Okay. So look at this. What do you see? Brown bear, what do you see? It's a famous song for kids, baby. You don't know. You will see what I'm saying after 5 or 10 years. Brown bear, what do you see? I see a little bird looking at me. Brown bear, what do you see? That's all I remember. Anyway, so what do you see here? In a perfect competition, this market share is 0, right? Negligible. That means the market price is same to the marginal cost. But here, this is imperfect competition. And this market share is not negligible. When there are two companies, this can be 0.3 or 0.5 or 0.7. When there are several companies, anyway, this can be 0.1, 0.2, 0.3, ... And about this term, the price elasticity of demand is typically very small, especially in power economics, the price elasticity of demand is very small. So that means even if your market share is small, still the price can change a lot. Okay, so this market price is heavily dependent on the generation quantity of each firm. Okay, so so this is less than 1. That means, if this is 1, then we have some market price. If this is less than 1, then the new market price at this imperfect competition, the market price at this imperfect competition is higher than the perfect competition. Because this is less than 1, then this should be greater than the previous case. The case when this is 1. You see what I'm saying? Okay. What I'm saying is, this is less than 1. So if we compare two cases, when this is 1 and when this is less than 1. So when this is 1, this is the market price at the perfect competition. Let's say there is a $10. When this is less than 1, my question is, the price would go up or go down? Go up. Yeah, it will go up because this is less than 1, right? So, in other words, this is less than 1. So at the optimal production, the marginal cost of generator I is less than the market price. Same statement but different perspective. In perfect competition, the marginal cost of generator should be equal to the market price. But here, the marginal cost is less than the market price, or the market price is higher than the marginal cost. So in this imperfect competition, the price goes up. Okay. Let's look at another example based on Kroner competition. $35, $45, same as before, and this is inverse demand curve. Suppose that, okay, actually we need to determine this quantity PA and PB, but just suppose that PA is 15, PB is 10, and see what happens. So the demand is 15 plus 10, 12.5. Here the assumption of Kruno model is that anyway the market will observe this total quantity. So very, very simplified model. Right? So actually we do not exactly know this inverse demand curve. Just an example. So market price is 100 minus 25, and the revenue 75 times 15. Yeah, cost 35 times 15, and for form B 75 times 10, and 45 times 10. So revenue, cost, and the profit of A is that, profit of B is that. Okay, and what we want to do, the firm A needs to determine its generation quantity. Firm B needs to determine its generation quantity. And this is just one specific point. So let's consider many other cases by changing the quantity slightly. So to do that, okay, in this case, okay, we will use this kind of matrix. Is it matrix? So yeah, okay. From the generation quantity of form A, generation quantity of form B, and this is the total generation or total demand. That plus that is here, and the price is determined from inverse demand curve, 100 minus that. So, and the profit of A and B can be computed in that way. So we did that. So 600 and 300, yeah, 600 and 300. And by changing the generation quantity of form A, 15, 12, 20, 15, 20, 25, 30, and form B, 10, 15, 20, 25, we can fill this matrix, kind of matrix. Do the same thing repeatedly. Okay? And we want to focus on the blue box and the green box. So the profit of form A, or so by changing the quantity, the profit of form A changes like that, or like that, or like this. Similarly, by changing this producing quantity, this yellow, green box changes like that, or like that, or like that, or like that. So as you see, my profit depends on my generation quantity as well as competitors' generation quantity. Okay? And okay, what I want to say here. Let's play the Kruno game. When this table is given to you, and suppose that you are an operator of firm A, then what would be your decision of production? How much you need to produce? Any idea? Yeah, you want to maximize your profit. So you need to focus on this blue box. What would be your choice? Actually, your choice would be 25, and the reason is because is it? Yeah, okay. Yeah, this is the equilibrium point, and let's see what happens here. if this guy does not change his action, by changing your action, you cannot increase your profit further, right? So this is the maximum point. And similarly, given this 25 from A, the profit of B, green, 200, 225, 200, 125. So by deviating from this action, you cannot increase your profit, right? So when they are here, they do not have any incentive to change their action. So in that sense, this is called equilibrium. Okay? Of course, this equilibrium point is different from the point where the profit from A is maximized. Yeah, we can find another point where the profit of A is higher than that one. But as long as they are here, they would not change their action, their strategy. Okay, so that's the meaning of equilibrium. And then suppose that why we cannot stay here? The reason is because when we are here, the firm B would increase their, when we are here, so when we here, the firm B would increase their generation from 10 to 15 because that gives higher profit. So if we are any other position, then either of two companies would change their action. Okay, so in this case, we have a single equilibrium point, but so when we talk about the game theory, you need to think about the two things. The first one, actually three things. Whether the equilibrium exists or not. This is just the case the equilibrium exists. Okay, the existence of the equilibrium, and if the equilibrium exists, then what? Is it unique or not? There may be several equilibriums. Okay, so as long as they are in equilibrium, they will not change. But there may be several that kind of equilibrium points. Third, what would be the third? What? How to get to that equilibrium point? That's the question 3. Okay? So how can we reach this equilibrium? That is kind of algorithm, the bidding algorithm, right? So those things, so the reaching the equilibrium means the convergence of the algorithm. Okay, A cannot do better without B doing worse. B cannot do better without A doing worse. That is called Nash equilibrium. By the way, who is the father of game theory? Do you know who is the father of game theory? Yeah, von Neumann. Genius. Yeah. So he established the concept of von Neumann architecture. That's the basic of computer architecture these days. He is the father of game theory. He is a Hungarian. If you read the cartoon book 야공만, you can find all of that kind of interesting stories. If you don't know, I will put that book in nice library so that you can enjoy that in the comfort sofa. Okay? Okay. Time's up, so let me stop here and we will